Are you struggling to find a job in IT, tech, or feeling unsure about where to start? It can be overwhelming with all the buzz around AI, ML, Gen AI, and Agentic AI, right? In this video, we'll help you cut through the noise and break down how these technologies work and why they matter. We'll explore what generative AI is and how it's transforming industries, the role of foundation models and how they are created, how transformer models complete tasks like sentence generation, key AI concepts like tokenization, word embedding, and decoders. Also, this video is day 1 of our AI track program, which is our paid program, where participants have invested more than $6,000. Many like Shrija, Shovik, Yash, and others have landed their dream jobs through our program. So we are offering you a sneak peek of one of our sessions so you don't miss out on this valuable content. And make sure to become a part of our upcoming free live masterclass on AI, ML, Gen AI, and Agentic AI with a proven 3-step framework. In this free class, you will learn key concepts like in-demand skills and certifications to kickstart a high-paying job in AI, ML, Gen AI, and Agentic AI. We'll cover how to build a strong portfolio, navigate career opportunities, and avoid common pitfalls in the AI or tech space. You can register through the link given in the description below.
Okay, so before we start today's session, as you know that it's going to be a quite lengthy training. We are going to discuss all AI, ML, Gen AI concepts. We discussed the introduction we had, and now we are moving towards the next step in this course, wherein we will be exploring services and lot many concepts. So just want to set certain ground rules before we begin. As you know that we have a mixed crowd here, and this course actually starts from basics of AI ML, that is from level 0, and it goes to level 3. So considering that, I request all of you to keep your questions relevant to the topic that we are discussing. While I'm discussing a topic, if you come across a question, I would request you to park your question. I will allocate a time. Let's say after I complete a certain topic, I will give you time for question answers, or maybe after each hour, we will have 5 to 7 minutes of QA. Okay, so that you can focus in this session. Because if you continuously start putting the things in the chat, the others will get disturbed. So as the feedback what we received, so considering the feedback, because many are freshers here, fresher to AI ML, and many have experience on AI ML, right? But as the course starts from basics, so we have to discuss basics of AI ML, and then we gradually move towards the advanced things. So those who already have the experience or knowledge of AI ML, just have little patience so that others can also get the benefit out of this training, right? So hope that's clear to all of you. So before we begin with today's topic of discussion, I would like to do a quick recap of what we discussed in last 2 sessions, because many were new, and because of the discussion what was happening, it was going towards quite advanced thing, and few folks were not able to understand those things. So for not for just for them, but for everyone, let's do a quick recap of what we discussed so far. Okay, so okay, let me get a pen over here. So we discuss the concepts of AI ML. So I would like to start with what is AI, what is ML, and then we will move towards the generative AI topic for today. So so let's start with the artificial intelligence, AI. So as all of you know, what is AI? We discussed this, and you must have heard almost it's there everywhere, right? In almost every industry, everywhere AI is being used. But if to put it in a technical term, so that will help you even for facing an interview, also clearing a certification. So we have to bound this terminology in a more technical way, right? We discussed the practical examples of that. I gave you the real-time use case and the practical examples to help you understand these terminologies, the concepts, but let's discuss it in more technical way. So AI is the field of computer science. You know that many of the colleges, they are offering these courses. So it is one of the field of computer science which is dedicated to solve cognitive problems, which is commonly associated with human intelligence. As we discussed other day, artificial intelligence it mimics the human intelligence. So what a human intelligence does, we are capable of solving cognitive problems, right? So similarly, AI is one of the field of computer science which is dedicated to solve the cognitive problem commonly associated with human intelligence. For example, creation, learning, recognizing, image recognition. Okay, all this falls under the cognitive thing. Now the goal with AI is to create self-learning system so that it can derive meaning from the data. Self-learning system. We don't want, like I gave the example of a school and then college, how we used to learn when we were a toddler. Okay, we used to learn through a supervisor, a teacher-based learning, right? That was the model. But now we don't need anyone like to sit and teach us. We do a lot of things we learn in our day-to-day life through self-learning, through experience. So the same thing we wanted AI to do. So AI is to create a self-learning system. That was the goal. That was the objective. That it should learn itself. It should be able to derive meaning from the data, right? And that is what it does. So as you likely have already experienced, I'm sure all of you or many of you have used ChatGPT, Alexa, right? Alexa takes the instructions, so it is again AI based. ChatGPT, whatever request you, whatever prompt you do, you get the output. So AI technology can respond meaningfully when you ask a question. It can create content for you, text content, images content, because AI systems can quickly process vast amount of data. They can be used to solve complex problems. Like, what are the complex problems? The real-time problem, fraud detection. It is, see, the AI, the power behind the AI is the data, right? So it is being trained on vast amount of data. And if as the data, it is the data on which it is being trained on, it is basically what exactly is happening. It is adding skills to the AI. Just like a human being, the more knowledge we possess, the more skills we possess, we will be able to solve more complex problems, diverse problems, right? Similarly, AI has that kind of capability. So it's about the data, vast amount of data on which it is being trained, and that is why AI can solve complex problems. So AI has become exceptionally powerful when it comes to finding pattern in data, also forecasting trends. Coming to machine learning, it is a branch of AI. Machine learning is a branch of AI, artificial intelligence. Also computer science. Okay, it's a branch of AI and computer science. So coming to machine learning. So machine learning, as I said before, we have to put it in more technical. We have to define it technically, right? So that you can face the interviews. You have to use this. While you explain, suppose if the interviewer asks you, explain it by using real life examples, then you can use all the examples that I have discussed in this section, right? But to start with, you have to provide a technical definition. So machine learning is a branch of artificial intelligence, also computer science. Computer science. And it focuses on the use of data and algorithm. So as already I told you, so now you will be able to quickly pick up what I am saying here. So it is focused on data plus algorithm to imitate the way humans learn. So machine learning models are trained by using large data sets to identify patterns and make the predictions. Because see, machine learning model is being trained on certain amount of data. But now as a new data, now it is being trained, the model is ready. Now, when we give some new data to the model, it should be able to understand that data. It should be able to understand the pattern, the features of that data, right? Only then it can make the predictions. Only then it can give us the meaningful outcome of the data. So it can identify the pattern. So machine learning models are trained on large amount of data set to identify pattern so that it can make accurate predictions. The best example would be product recommendation for a customer who is shopping online. These days we get a lot of product recommendation. Many years back that was not the thing, right? Or for example, when you search something, let's say you make some Google search for some information. What happens after that? Automatically, you after that, whenever you use your mobile, you get lot of recommendations on similar line on that particular thing what you were searching for. Whether you wanted to book a flight or you were searching looking for some product to buy, you get a lot of recommendation as you go to website, right? So that is all uses machine learning. Now coming to another important concept that we discuss is deep learning. So deep learning is a type of machine learning model that is inspired by human brains. Just like our brain has got neurons, it is a multiple collection of neurons interconnected together, and brain has tremendous capacity to process complex information, to process complex data, right? Similarly, the deep learning model has that capability. Deep learning model of machine learning. So it's again a subset of machine learning. It's inspired by human brain. It uses layers of neural network, what we call it as artificial neural network, ANN, to process the information. For example, recognizing the speech, human speech, recognizing objects, images, are some of the things that a deep learning model can perform, can do. Businesses can be more efficient and better serve their customers by being able to more accurately forecast demands. Let me give an example. Let's say a taxi company uses AI to position their cars in location and at times when customers are likely to need them, where they are supposed to position, which are the places where they will get more customers. Okay, so they uses AI for this. Or another example, financial institutions like Mastercard can detect fraudulent transactions by using AI to detect an anomaly activity, anomaly behavior. Or HR department can use AI to process resumes and match the candidate to the roles, to the open roles, and help the hiring manager to be more productive. That will ease the job, save the time of HR. So these are some of the examples which we discussed in the previous session. Again, I am reiterating it. So using a technique called regression analysis, an AI model can process the historical data. Because what data we are providing to train the machine learning model is all the historical data, right? So a technique which is known as regression analysis, AI model can process the historical data, which is also known as time series data, to predict future values. Example, a store need to know how many salespeople it would need on a given day to service customer. For example, on a weekday, it's going to be a different count compared to a weekend or compared to a festival, whenever some festivals are there, or compared to whenever a sale is announced, right? Some sales are announced. So a store need to understand how many salespeople it would need so that it can serve the customers better way, right? So an AI model can analyze the pattern in and forecast in the future. So what the AI model is doing, it is using the past data, that is the historical data, and it is predicting the future. Okay, so based on the historical data, based on the number of footfall in the store on weekdays, weekend, on promotion days or festivals, it will predict the future. Okay, so that they can have enough staff to serve the customer. So predictions that AI makes are called, what is it known as? Do you remember, guys? The prediction what a artificial intelligence does is known as, what is that special terminology? Predictions that AI makes is known as, no. Perfect, Murli. Yes, inferencing. Inferencing. Okay. So that's why I said terminologies. You might be understanding the concept, but you need to remember the terminology, right? So inferencing. Inferencing, as somebody asked me, I remember in previous session, what is inferencing? So I'm repeating it again. Predictions that the AI makes are called inferencing. Okay. So what is an inference? Inference is basically an educated guess the model makes, and it is being educated how? On the data. The data on which it is being trained on. Based on that, it makes a guess. Okay. So the model gives a probabilistic result. Okay. Probability. Okay. These many salespersons are required. Some probability. So it is based on the educated guess. That is what is prediction, and that is known as inference. Because AI can recognize patterns in data, it can also detect when there is a deviation from the expected pattern, and that deviation is known as, yeah, tell me, what is that terminology? AI can recognize pattern in data. It can also detect when there is a deviation from the expected pattern, and that deviation is known as, no.
Deviation.
Yeah. Okay, I'll give a clue. It starts from A.
A deviation.
Anomaly, yes. Anomaly. Okay. So the deviation accuracy is not, accuracy is actually a metric, right? So if it is deviating from the expected one, that is anomaly. Okay. Now moving to generative AI. So this is the next step. Gen AI is the next step in artificial intelligence. Generative AI can have intelligent conversations and generate original like content, like stories, images, videos, even music. Okay, so that is generating original like content and more intelligent conversation we can have with Gen AI. Machine learning is the science of developing algorithms and statistical models that computer system use to perform the complex tasks without giving explicit instructions. Okay, what is machine learning? Machine learning is the science of developing algorithm and model, statistical model. So other day somebody was asking if we are developing model in this course. No, we are not doing that. We are actually building the model, right? We are not developing the algorithm. So even developing algorithm also falls under machine learning. And these are used by your computers to perform complex tasks without giving explicit instructions to the model. Now you can think of, now, okay, now machine learning, as we discussed that, it is being trained on data, historical data, and it identifies pattern in the data. To train the algorithm to produce the output we expect, we give a data to the machine learning model, and the data consists of features. What do we have in the data? See, we are using the data to train the machine learning model so that it can generate the output, right? It can provide us prediction. That is our objective. Now we train the algorithm so that it can produce us the expected output. The data what we provide has got features. Data consists of features. Now, what a feature mean? You can think of feature as a column in a table. As a columns in a table. Those are the features. Now, simple example to help you understand features, because we are having a good discussion and the lab is also there on the features. But if you get the clarity on the concept, then next time when I use feature or feature reduction or feature engineering, you will be able to understand what does it mean. A simple example is that now we have this session, we have multiple folks joined here, around 50 are there. I would want to take class attendance. Okay, so to take class attendance, I have prepared one Excel sheet with serial number, name, date, let's say time, and your geographical location. Okay, so this serial number, name, date, time, location, these are the different columns that I create in my Excel sheet, and these are nothing but the features. Now, for taking attendance, how many different, let's say I have added few more columns. I have also added your designation. I have also added your education, like your qualification, okay? Qualification. I have also added your salary, how much you're earning right now, your marital status, okay? Now tell me guys, does it make sense for taking attendance? Do I need to add all these features? So many features, does it make sense or does it require? I'm sure your answer will be no for this. Yeah, it's not required, right? So then what we need to do? If such data is being given to a model for training, okay, and there is a problem, like same thing, let's say class attendance is the business problem, okay? Now, if we are giving so much of data, what we are doing? We are basically complicating the model. We are overloading the model, bombarding with a lot of features which are not relevant to the problem. So what we need to do? We need to drop, right? We need to drop the features. And that falls under whether we have to drop the features, we have to select the important features, we may have to transform it. This is all falls under feature engineering. Okay, feature engineering. So we will be discussing how we perform that, but just an intro of that. So your data consists of features. Yes, this data is provided by humans. Data is generated by either application, data is generated by humans, okay, generated by tools. So data comes from different places. So features are columns in a table, or feature can be a pixel in an image. Now, if it's an image data, a pixel is a feature. So we continue to train the algorithm by giving it more known data to analyze. And its task is to find the correlation between the input data features and the known expected output. Okay, it try to correlate. And the adjustments are made to the model by changing the parameters, the values, until the model reliably produces the expected output. Now, to give you a simple example to help you understand this point, what I am highlighting it here. See what I said, I repeat my statement here. We understood what is a data, okay? We use data for training the model, fine. A data consists of features. Now, what are the features? You can think of features like a columns in a table or a pixel in an image. Now, we give this type of data to for algorithm to analyze, to find the correlation between the different features, so that it can provide us the expected output, right? And now, as I like for the class attendance, if I'm putting marital status and salary, it will not be able to correlate. What is the use of that, right? So that will have a very low weightage in the machine learning. You can say machine learning, when we perform the data pre-processing, it will not have much weightage for such features. So what we need to do? Okay, feature engineering, one thing we do, fine. After doing feature engineering, let's say still we are not getting the expected accuracy. Okay, let's say I was expecting the accuracy, the prediction accuracy of my model. I was expecting 85%, and it is giving me somewhere 75%. Right? So what I need to do? I need to tune certain parameters. I need to adjust certain parameters. Now, to simplify this point, uh, all of us use AC, right? We use TV, we use different electronic gadgets, right? What do we do? Suppose the picture quality is not good, or the color is not good on a TV. The color is very dark. What do? We use certain knobs or the TV remote to adjust the color, to adjust the clarity, picture clarity, to adjust the volume as per our expectation. That is nothing but adjusting the parameters. On a similar line, model will have also lot of parameters. So that we adjust to get the expected accuracy so that it can reach to this. Okay? Until the model reliably produces the expected output, we perform the adjustment of internal parameter. So a trained model is then able to make the accurate predictions and produce output from new data that it hasn't seen during the training. And this is known as inferencing. Okay. Now, hope it is clear so far. I would like to now discuss some new points which we did not discuss in previous session. So let me just quickly check. Yeah, so that is what Jayaprakash. I was about to come on the different types of data. Okay, that is my next point of discussion. Anubhav, hope you understood what are parameters here. Internal parameters. Every gadget, AC also comes with internal parameters. We control the cooling by using its the temperature control is there, which is internal, which is integrated, right? Likewise, our model will also have parameters that we use to fine tune or that we use to improve the performance of the model. No, features. Okay, features are different, parameters are different. Anubhav, both are different things. They are different. Features, let me tell you. Features, to give you an example of a TV, same example. TV has a feature of displaying an image. TV has a feature of giving you a video content, displaying a video content, displaying an audio content. That's an inbuilt feature of TV, right? Those are the features. TV is meant for entertaining. That is the feature of TV. But parameters are something which we tune or which we adjust to improve the performance or the accuracy. Right? Okay. Now, fine. Hope you understood what is AI, what is ML, what is deep learning, what is generative AI, what is a data, what is a feature. Okay. And also we discuss about, yeah. So now the thing is that now data, when we talk about data, data comes in different formats, right? There will not be just one format of the data. Data, two things are there. Data will be there in different places and data will be there in different format. What we call it as different sources, which are nothing but like some data is there in one database, some data is there in storage service or storage media, some is there in some other database. So data is there in different places. That is one thing. And the other one is the structure of the data. So one type of data is a structured data, which is easiest to understand and to process. The structured data is very easy to understand and process. Hope you know what is structured data, right? So the example which I was giving about the Excel sheet for taking the class attendance, it's an example of a structured data which will have a schema. It's easier to process and understand. So this type of data is stored as rows in a table with columns. So a structured data will have rows and columns. It is basically, it consists of records and fields. So which can serve as the features for an ML model, right? We discussed the column acts as a features. Example of structured data is CSV file. Okay, a text file like CSV or any relational database. Okay, relational database services. For example, like we have RDS service on AWS platform or data warehouse Redshift. So these are all examples of structured data. Text file like CSV or stored in any relational database services like RDS or Redshift Okay, these are all relational. It can be queried using structured language, or what we call it as SQL. Right? So this is all the structured data. Now for model training, it would be it would be exported, not imported, it would be exported to the storage service, S3. S3 is one of the most popular service offered by AWS, which is known as simple storage service, and the data will be exported to S3. So in machine learning, S3 is very much in use because when we want to build a model, we have to have huge amount of data, and S3 has unlimited storage available, right? So it's the primary source for training data, because one advantage is that it has unlimited, virtually unlimited storage capacity, and it can store any type of data. Any type of data S3 can store, and it is cost effective also. Means with lower cost, you can keep large amount of data on S3 and unlimited storage is available. Other type of data is we have, apart from structured data, what are the different types, guys? Let me see. What are the other types we have? Okay, I'm reading the comments over here. Is same data we are using for AI and ML? If both are same, what is the difference? Shravan, AI, ML, it's not like that. See, basically, data is being used to train a model. Think that you are a model. Okay? You are a model, and to create a model, you need to upskill, right? To be able to understand AI, ML, to be able to build a ML application, ML based application, you need to understand these skills, right? You need to upgrade these skills. So data we use to train a model, to build a model. And AI is basically, that is, it uses the models which are already there. AI services uses the models which are already there. So machine learning is the one where it gives us an opportunity to create a model of us. Okay, Ramakrishna has come up with an answer. Unstructured data. Okay, Shaila also unstructured data. And one more is there. Structured data, unstructured data, and one more is there, guys. One more type of data we have. Semi-structured, correct. Okay, so we have structured data. See, the data gets stored in different way. For example, let's say the Excel sheet example is a structured one. Now, what is the example of unstructured one? You are, let's say you are keeping lots of data, you are downloading something on your mobile phone, some images you are downloading, some document you are downloading, some photos you are taking. What is that? Different type of data, you are storing it in your mobile storage. This is completely unstructured, mix of data, correct? This is unstructured. Okay, so it is, data falls under three different types. One is structured, the other one is unstructured, okay, and the third one is semi-structured. Structured, unstructured, and semi-structured. Okay, so now what these types of data means? Semi-structured data doesn't completely follow the rules of structured tabular data. A structured data is more tabular, right? The example which we discussed. So it doesn't follow the schema or the format of the structured data. Unlike data in a table, the semi-structured data elements can have different attributes or missing attributes. So the example of semi-structured data is a text file that contains the data in a JSON format. JavaScript Object Notation, JSON. Hope you all know JSON format, right? It will have within the curly braces, the format will be the key value pair, kind of key value. So I'm just giving an example, key and then value of that, and like this kind of format will be there for a JSON format, those who have not seen that. So that's a semi-structure. So in a document, like the features are represented as key value pairs. So Amazon DynamoDB, DocumentDB with MongoDB compatibility. These are the examples of transitional databases built specifically for semi-structured data. Okay, unstructured data which will not have any predefined structure, and it can keep any format data, not just one format. Okay, unstructured data. So for training machine learning model, the data would be exported to S3. Unstructured data is the data that doesn't conform to any specific data model and can't be stored in table format. Example of unstructured data, mix of everything as we discussed. The text data, image, videos, audios, social media post. Okay, so unstructured data is typically stored as objects. And the AWS has an object storage service. What is the object storage service in AWS, guys? What is the name of that service? Yeah, you're right, Obed Pikmar, all of you. Yeah, perfect, very good. So the object-based storage service in AWS is S3, which can keep any format data, PDF, audio, video, HTML, text, binary, whatever, whatnot. It can just have any format file. So mix of everything. That is your unstructured data. So the features for machine learning are derived from the objects by using
So, Sonal, what is the example of unstructured data like?
Yeah. So unstructured data, you can just have an image file, an audio file, a video file, right? So machine learning is not just limited to text data. It can work with, it can identify objects, it can understand the videos, right? So it can deal with different type of data, different modality data. Machine learning model can deal with. So
Thank you.
yeah. Fine. So coming back to this one, what I was talking about, the features for machine learning are for, I'm talking about the unstructured data, how the features are derived for the unstructured data. Unstructured data is stored in S3. S3 is a object-based storage. Everything it will treat as an object. Each type of, any type of file, okay, it will consider that as an object, which is a generic terminology. As I said, could be an HTML file, could be a PDF file, could be a TXT file, could be a JPEG file. Okay, so any format file you can keep it in SD. That is an object. Now, how the machine learnings are deriving the pattern from these objects, right? That is important because we have some as audio, some as video, some as images. So it derives the pattern from the object by processing these objects or the object file using a technique tokenization. It uses a technique tokenization. A tokenization is the one which breaks down the text into individual units of words. Now, for example, generative AI fundamentals, right? Now, this is let's say, a line, a statement. Now, what in a tokenization, what it does, it will break down this text into words, individual units of words or phrases. So, gen is one token, AI is another token, fundamental is another token. Like this, it will break it into words, multiple words. That is what is tokenization. More about that we are going to discuss in today's session only. Okay. So, yeah, so that is about structured data, unstructured data, and semi-structured data. Time series data is important for training model that need to predict the future trends. Okay, time series data. So each data record is labeled with a timestamp and stored sequentially. Time series, certain data is based on time. Okay, so time date is important. So for future trends, like okay, today, let's say today is 27th of July, right? There is some incident happened today. So what is going to happen, or based on the 27th August, after a month, right? Certain predictions it has to make based on the time, based on the date, right? So this example shows the performance metrics for microservice.
So
Like
time series data can be structured, unstructured, semi-structured, correct?
yes, correct. Okay. So as I was talking about the example about the performance metrics for microservices, like including the used memory, CPU percentage, the transactions per second. Okay, all these are useful time series data. So yeah, So this is one thing about the introduction of this. Now coming to the benefits of, so we discussed about the terminologies, right? Now let me talk about the benefits, a quick benefits of artificial intelligence. Fine. So coming to the benefits of artificial intelligence, AI offers numerous advantages across various domains, across almost every industry. Now, if I talk about few sectors, let's say AI is used for in the manufacturing industry, right? For quality control, AI enables finding the product defects through, how does it find the product defects? Through CV, computer vision, and what we call it as predictive maintenance. Predictive maintenance by analyzing the sensor data before something goes completely down, before a problem becomes a disaster, or before something becomes a problem. Okay, it is able to find the defects, right? That falls under predictive maintenance by analyzing sensor data. If it finds that certain manufacturing unit or certain machine in a manufacturing unit performance is deteriorating, it's going down, okay, it will detect, it will identify the defects and provide you much before the information so that you can take the action. So through computer vision and predictive maintenance by analyzing the sensor data. So this reduces waste, it reduces downtime, it reduces the it also optimizes the cost. Otherwise, if something goes wrong and something becomes faulty, it takes a lot of time to bring it back, and that will be a it will impact the business and in turn the revenue, right? Another, I would say, healthcare industry, right? Health sector, AI is being tremendously used. AI can assist in diagnosing the illness. It can diagnose the illness by analyzing the medical images, by analyzing the medical data, by analyzing the X-rays, the MRI reports, and predicting outbreaks by monitoring global disease pattern. See, a doctor, if you go to a particular doctor, okay, you're facing some challenges, health issues, you see a doctor and doctor analyze and prescribe you certain medicine and all. One particular doctor will have certain limited knowledge, right? But AI has been trained on vast amount of data. So it is like AI will have the knowledge of millions of doctors, millions of reports on which AI been trained on. So it can become more, you can say, useful for diagnosing the illness, for analyzing the disease, for analyzing the images, the different reports, and providing you a more accurate, you can say, the treatment plan, right? So this can potentially save lives and improve the patient outcome, right? So this is very much useful, and also for drug discovery also AI is very much in use in healthcare industry. If I talk about the customer experience, AI is powered self-help, a recommendation system. It can enhance the user experience by providing a personalized experience or personalized solutions and tailored content. It suggests based on your test, based on the behavior, user preferences. So it improves the customer experience. AI also plays an important role in decision making processes. Decision making. It can forecast demand accurately. Let's say you are into you are running a shop, fine, or let's say a mall. Now different outlets are there, or let's say you have a big supermarket and different products are there in your store. Now you need to understand how many products are there in your stock and how many products are required. Basically, you will have to understand the current and the future demand. Accordingly, you will have to stock the products in your inventory, right? So AI can accurately match your demand and supply, demand versus supply, or supply versus demand. Okay, it can match this. It can forecast the demand accurately, preventing overstocking or understocking. Like if you overstock the product, it will be like a dead stock. If you understock, you will lose the business. So AI helps in accurately predicting this. It can also detect fraudulent activities, protecting businesses from financial loss. Okay, so lots of use cases are there. AI offers you, those are the benefits of AI, and that helps you to uh, make the right decisions. Okay, choosing the right. So AI has the capability to recognize patterns in historical data and make the probabilistic predictions. It is probability. Okay, I have a question for you guys. How many of you believe that AI provides you 100% accurate prediction? The prediction of AI is 100% accurate. Do you feel it is 100% accurate, or do you feel it is less than 100%? Okay, let me
Less
see.
than 100%.
Less than, correct. Perfect. So all of you have the good information. You know that yes, there is always improvement. Correct. It can never be 100%. You should never expect that it will give you 100% accurate, because it is probability. Yes, perfect. Yes, JP, you're right. Probability. It is like probability, right? Even as a human being, when we make some assumption, or when we based on our gut feeling, based on our experience, when we suggest something, it's not necessary that it is going to be 100% true or 100% correct, right? So yes, it is not 100%. So keep always that in mind, and always do not just 100% rely on AI ML. Whatever it is generating. Simple example, let's say you have used a chat GPT or any other tool to compose an email which you want to send to your boss. Make sure that you read. Do not just copy paste and send it, right? Though you have prompted, you have given a prompt to compose a mail, but still you should look for the wordings and look for the context. So it is very important. Do not 100% rely on this, because it is based on historical data and it is probabilistic, right? So remember, it can recognize pattern. All the machine learning model can recognize the pattern in historical data and make the probability predictions about future trends or outcome. That is what in simple words. Okay, now moving to generative AI fundamentals. Okay, before I go for that, one more thing which I would like to recap is machine learning pipeline. Okay, so machine learning pipeline you call it as, or machine learning life cycle you call it as. Okay, life cycle. So always the machine learning. Now, as I said, again I will recap this, like when a machine learning is required to be used, when to use machine learning. Not everywhere you should use machine learning and complicate the things, because using machine learning is not an easy thing, right? It comes with its own challenges, it comes with its own risk and benefit. So when the problems are simple, keep it simple. Don't use machine learning. When it is very complex and it requires it has to, you can say, analyze large amount of data, and the problem is recurring, and on large amount of data and dynamic and real time prediction, all these things you should opt for machine learning. So the first step is problem formulation. The first step in machine learning life cycle is problem formulation. You have to formulate your problem. Unless you understand your problem, you cannot find a solution for that, right? So understand the problem, define the problem formulation. Once the problem formulation is done, the next step is going to be your data processing, data pre-processing or data processing. Now, data processing has got multiple steps are there, which I'm not going to discuss. But problem, because see, once you formulate the problem, you know that what is that you want to fix or you want to use for the machine learning. Accordingly, you will gather the data, right? Because data relevance is very important. You cannot use all the data for all type of problem, or any data for any type of problem, right? So data always differ based on the problem. Fine. You gather the data, you process the data, you make the data ready for training your algorithm. So next step, once the data is ready, you will be starting with your model training. Okay. So you start with your model training, and while you train your model, while you start this activity, you will be selecting the algorithm. So as I said, if you remember, a machine learning, two important things are there. To build a machine learning model, we would need a data and an algorithm. To build a machine learning model, these two things are required. Okay. So data, relevance data, and algorithm. Different algorithm is there for different problem, right? Different machine learning problem has got different type of algorithm. Keep that in mind. For example, I want to calculate 48 divided by 32.5 into 128.8, something like this. What I am going to do? I am going to use a tool, Calci, right? I will be using calculator as a tool. If I want some other thing to be done, I want to see the current, you can say, what is the time? I will be using a time tool. I want to see the current temperature. I will be not using the Calci to see the current temperature in my city, right? So I will be using different tool for different things. Likewise, based on our problem, what are we trying to address? Accordingly, we will have to use the algorithm, right? So if you remember, we discussed the three different types of algorithm, right? We have supervised, we have unsupervised, and we have reinforcement. These are the three different types of algorithm that we have. Okay, we will discuss again this later. So I will be selecting the algorithm here. My algo selection while I start my model training. So my algorithm selection, I will be providing the place where I kept my data, and then the machine learning model training starts. Once the model is trained, the next step is to evaluate the model, validate the model, right? We have to validate what we have built. If suppose during validation we found that, okay, initially while we set the business goal, okay, I wanted the accuracy. I said the accuracy I'm expecting from the model to be 88%. Fine. So while I'm validating, I'm checking if it is giving me 88% accuracy. If not, I will have to perform certain tuning. Okay, what we call it as a hyperparameter tuning. So I'll perform the tuning. And once it meets my business goal, I will start deploying it. Deploy for inferencing. I will deploy my model. Okay, so this is the machine learning life cycle. This life cycle we use to build a model, to build our own model. Now, why to build a model? We have lots of models already available, ready to use machine learning models are there.
Can
Ready
I,
to use machine learning models. Yeah.
where to deploy actually? Say after validation, say
We
88%.
can we can deploy it on the machine. We can deploy it on the edge devices. We
Uh,
can integrate with our application. Okay.
means like say other applications we deploy on EC2 or say
Yeah. Yes.
containers Kubernetes. So these models actually little bit if you explore where we can
Okay.
deploy little.
Okay. So just understand the pipeline different phases. Deployment, anyhow, as I said, we are going to do all this practically. So you will understand how do we deploy and where does it get deployed. We are going to build our model. We are going to deploy the model. We are going to use it for inferencing also. I am going to showcase this end-to-end demonstration,
Oh,
right? So
yeah.
you
So
will get a
Sonal, I'm little bit like confused here. So you said that the second step is data processing, where we will gather the data and different problems have different algorithms, right?
gather the data in different, what you said, problem?
Like you were saying that like the second step, data processing, this
Yeah.
means that we will gather the data and then like for the problem, and then we
Mhm.
process it, because and then each problem have different algorithm. That's what you were saying, or a different
Uh,
model. Like
for different type of problem, see, we have basically different sets of algorithms are there. Based on what type of problem you're trying to address, accordingly you will have to use the algorithm. Or I would say other way around, based on what is that you are expecting from your machine learning, accordingly the outcome what you're expecting, the goal what you have set, accordingly you have to use the algorithm. You
what
got
is
my point?
then like what do we call data processing? Like what do we are doing in data processing?
Okay, that's a good question. See, I gave you one example of Excel sheet taking a class attendance, right? So the various features, the various columns which were required was serial number, name, date, and that's it. Three columns were sufficient to take the class attendance. But what I did, I added lots of additional columns. Now this data is so heavy, which and it has lots of irrelevant features which are not required for my problem, right? For my objective right now. So what I will do, I will have to remove those additional features. That is one thing. Second important thing, what if lot of missing data is there? Let's say some of the students are absent on certain date. So it's missing data is there. Means that particular row doesn't have any information, like absent is not marked, neither present is marked, not absent is marked. So it's a missing data, null data. Or some of the column has the student name mentioned in different language. Almost entire data is in English, but let's say some of the data in my table has a different language data. So basically what we need to do in pre-processing, we have to clean the data. We cannot give raw data for building a machine learning model. We have to bring it in a, we have to make it a quality data. Bring it in a single, like a proper shape has to be given to the data, removing all the inconsistency from the data, converting it to or transforming it into a format supported by my model, supported by my not model algorithm. Okay, so let's say my algorithm supports tabular data, I have to convert that into tabular form depending on what algo I'm using. So basically cleaning is data pre-processing.
Okay. And then bring
Okay,
it into a supported algorithm, and that
correct.
algorithm could be supervised, unsupervised, and reinforcement.
Exactly. Yes, you're
Oh,
right.
okay.
Yeah.
Thanks.
Okay. So I
Then you were saying that there are different models for machine learning. So what does that mean? Like, uh,
okay. Now see, once this process we discuss is a building a machine learning model. Fine.
mhm.
Now we have built this machine. Let's say the class attendance. Let's talk about the problem was class attendance. Fine. So we have built the model. Now what kind of model is this? What problem will it solve? It will solve the class attendance problem, right? Can I use to analyze the image? Can I use this model to analyze the image? No. Just
Okay,
like
okay,
we have, right? Just like we have different type of algorithm, we have different type of models we have. Some
okay,
models can deal with text data, some models for image, some models for video, some. So it is like different models has got different modality or different type of problem it can solve.
okay. Okay, so this was we were just talking about how the model internally works. Okay.
Yeah. Okay. So that's right, Anubhav. Feature engineering is part of data processing. I hope you got the answer. And yeah, right. So this is how the machine learning life cycle is. This is to build the model. But as I said, we have lots of ready to use machine learning models are already there. So it is not always required for you to build the model. You can just go ahead and start using the ready to use models. That is what Gen AI, right? Gen AI uses the ready to use foundation models, right? So if it is not, let's say if the model, let's say you have a very specific requirement, domain specific. What models are available in the market are generic models, right? More generic one. Like for example, ChatGPT. ChatGPT uses a model. ChatGPT uses a model to generate new content, to summarize the content or whatever you want, right? So, if suppose you have a specific requirement, let's say you are from a manufacturing industry and automobile industry, and you have whenever you are asking some question to ChatGPT, which is very technical to your industry, your automobile industry, it is giving a very generic answer, right? So you would want to have a more specific one. It should have, your model should have a domain knowledge. You are expecting your model to have a domain knowledge. When this is required, what you need to do? When the model needs a domain knowledge, when a model should be capable of providing a more specific domain information, what is that you need to do? Or what is that terminology known as? You are complementing the model with the domain knowledge. So what is that known as, guys? I'm sure many of you knows this, but you need to recall that terminology. No. RAG, yes, RAG. Retrieval Augmented Generation. Okay? As I said, model is generic, but you want to make it more domain specific so that it can handle all, or it should be enriched with your organization information, knowledge, proprietary knowledge, right? So you have to opt for RAG. There was a question, how is unstructured data processed? So if you remember, I already explained you, unstructured data is processed through tokenization, right? Okay, fine. So now we are good to go ahead with the generative AI fundamentals. Pradeep, it is which model to use? It completely depends on what is your business requirement. For your requirement, you will start researching on the different model options which are available, the ready to use model options. And then you compare with the features. And then you opt for. We have open source models are there. We have platforms, proprietary models are there, right? So you start comparing and then you start using it. Okay, Ankur, we will be discussing that in this topic itself and in the generative AI fundamentals, right? So let me start this slideshow. Okay, so Gen AI fundamentals. Let's begin with this topic for today. And what is generative AI? So as already we covered, like artificial intelligence, generative AI is powered by machine learning models. So ultimately, model is the backbone of AI, right? The complete AI ecosystem. AI. Under AI, we have ML, which is a subset of AI. Then we have deep learning, we have generative AI, we have agentic AI. Everything is being powered by models. Keep that in mind. Generative AI is powered by very large models that are pre-trained on vast collection of data. Okay, so basically generative AI is powered by LLMs, large language models. Now, before we discuss on generative AI, what is AI? Traditional AI. The comparison between traditional AI and generative AI. So, traditional AI systems are designed to learn from data and make the predictions. Okay? Learn from data and make predictions. So, these systems excel at analyzing input data and providing insights or recommendations based on the training, based on it, how it is being trained on. Now, in contrast to this, the generative AI, Gen AI system has the capability to create new solutions and output based on the knowledge gained from their training data. That's why the name generative. It can generate new content. Okay? But the traditional AI, normal AI, It can analyze input and provide the recommendation based on their training data. So instead of the generative AI, instead of making predictions, generative AI can generate the novel content, ideas, or solutions which is tailored to specific need. Okay. So a key distinguishing feature of Gen AI is the use of FM, foundation models. These are large pre-trained models that have learned patterns and representations from vast amount of training data across various modalities. Text, image, these are the different modalities, okay, on which it is been trained on. Natural language, it can understand different languages, it can deal with different language data, images. So foundation models serve as a starting point which can then be fine-tuned for a specific use case or a specific task, which I have already told you earlier. Okay, so generative AI uses foundation models, and foundation models are pre-trained models. These are ready to use models, and it has learned pattern from vast amount of training data, and the training data has different modality data. It is being given different type of data is there, not just the text data. Okay, so large machine learning models that are trained on a broad set of unlabeled data and are fine-tuned to a wide range of applications. So we can fine-tune the foundation model. It is always good to fine-tune it to tailor as per your requirement, to make it domain specific instead of building your own model, building it from the scratch. That is going to be more time consuming. Fine-tuning is going to be simple and less time consuming. Okay. Now coming to large language models, LLMs. AI that is trained on vast amount of text to interpret and generate human-like textual data. LLMs more are being trained on textual data. So the ability to create a new content differentiates the generative AI from other machine learning approaches. Generative AI uses various architecture for generating the new content and algorithm. For example, variational autoencoder VAE or GAN GAN, generative adversarial network, and diffusion models to achieve this capability. Okay, it uses different models, different architecture, because it can generate different content, different type of content. So for that, definitely it has to use different type of models, right? So generative AI is a specialized subset of deep learning technique, right? Now coming to generative AI services on AWS Bedrock. Amazon is focused on these three macro layers to Gen AI, that is compute, build your own model. We use compute, then build your own model, and then foundation models as a service. These are the three macro layers to generative AI. Foundation model as a service. Now this includes Amazon Bedrock service, which provides access to LLMs and other foundation models. Let me quickly get my console here to show you. Now, as I go to the Bedrock service, so this is AWS Management Console. I go to Bedrock, and you will find lots of, like yesterday also I showed you, once again I'm showing you. Here, we have got lots of models. So if I go for model access, let's say I want to activate So these are the different models that we have. And you can see the modalities highlighted. AI 21 lab, under that we have different type. So text, now there is Amazon, Titan embedding is there. Then we have image, text and vision. So different modalities supported. These are the different foundation models. LLMs are available here. Some are foundation models, some are LLMs available here. Okay, so this is Amazon Bedrock service. So coming back to Amazon Bedrock service, here, so Bedrock service provides you foundation model as a service. Means you already have foundation models ready to, like pre-trained models are there available, which you can use by using Amazon Bedrock service. So it provides access to large language models and foundation model. Next, you have built your own model. Now, this refers to service like SageMaker and SageMaker Jumpstart that you can use to train and deploy your own custom machine learning model. If you want to, if you don't want to use the ready to use model like foundation models, you can build your own model, machine learning model that I have told you. And to build your own model, which service AWS provides? SageMaker. You can use SageMaker or SageMaker Jumpstart to build your own model. Then you have got compute. Now this category includes AWS Trainium and Inferentia, which provides specialized hardware and instances optimized for machine learning workload. Because for machine learning workload, we would need a good processing power. So this is a specialized hardware which is meant for machine learning workload. So these are available to us provided by AWS, and we can deploy it by using EC2 service. So this is the compute. Okay, so you can build your own model. You can use the ready to use model. To build your own model, SageMaker is there, which is managed by AWS, or you can build your own model using the compute service EC2, or you can go ahead ready to use the foundation models are there, which you can use by using the Amazon Bedrock service. So there are a few questions which I would like to take before we proceed. Ramakrishna says, can you explain the compute one more time? So let me go back to the visual. So here is the visual for compute. So here is the visual for compute. So we have a specialized, as I said, we have a specialized hardware type of instances being provided by AWS. One is the Trainium, the other one is Inferentia. This hardware or these specialized instances are especially used for machine learning workload. When we want to build our model, when we want to deploy our model for predictions, these are the specialized hardware that we use. Because see, what is required when we are building a model, we would need a high processing power. We would need a good throughput when we deploy the model. We want low latency and high throughput when we deploy the model. It should be able to predict in real time, right? When I'm using my model for prediction, let's say I would want a real time prediction. So I want it should not take much time for prediction. So low latency requirement is there, right? So for that I use Inferentia. I use Trainium for building the model because I would need the model has to extract the features from a large data set. So it would need a good processing power, right, at a lower cost. So we opt for Trainium. Even if you are using Amazon SageMaker service to build a model, in backend it will be using these specialized hardware, right? Okay. Okay, Jasmine, to answer the question why we would want to build a model, a simple analogy I would like to give you here, Jasmine. It is as good as you buy a ready-made house against constructing your own house. So what kind of control you will get when you construct your house against you buy a ready-made house? It is just like that. That is how it differs. Okay, If you have more customized requirement, more specialized requirement you have, very specific requirement you have, okay, and you are not getting a model readily available model which will match to your requirement, you have to build your own model. Yeah, anyhow, that we are going to discuss, Pradeep. Those are the different models, different types of models that we use for in the Gen AI for generating the new content. Okay. I will come back to this one, Pradeep, to your question. Before that, I would like to take, as I was going in a sequence, Manav's question. In which situation, under which situation, we will be using foundation models and LLMs? That's a good question. If you remember, I told you like LLMs are trained on textual data, text data, and foundation models supports different modality, different type of data. So it depends on completely on what is that you're expecting or what is your business goal. If you are expecting like a chat GPT wherein you will be prompting something, expecting content generation or some text summarization, basically text based data, you can opt for LLM. But if you want to generate an image analysis or something like that, you can opt for foundation model. So it depends on the modality, okay, the type of data. So foundation model supports different modality data, text, audio, video, and the LLM supports the text data because it is being trained on the text data. Okay, so depends on the requirement. And yeah, so coming to next question. Okay. Ankur says, what is the difference between building your own model versus compute? Building your own model versus compute, see, Ankur, there is no difference. We should not be comparing this. Basically, see, to build your own model, you would need a machine, right? So either you can build your own model on by using an Amazon EC2 service, wherein you will launch a VM and you will start launch a VM of this type and then you will start building your own model. Or you can build a model using Amazon SageMaker service, which is this service is designed for machine learning only. It is a dedicated machine learning service. So you can build a model using SageMaker. SageMaker will in turn use this specialized hardware. Okay, specialized instances it will use. So ultimately, whether if you want, you can do it directly, but EC2 is not just meant for machine learning workload. You can use EC2 to deploy any application. You can create containers, you can deploy a database, you can use it for different use cases. Okay. So coming to your question, Pradeep says, what is VAE and GAN? So basically, as I said, these are used for by generative AI to generate a novel content, to create a novel content, right? To provide you some creative content. So these are encoding techniques. WAN abbreviates as variational autoencoder. So these are encoding techniques, and GAN abbreviates as generative adversarial network. So as I said, if you remember in the first visual itself, generative AI fundamentals or introduction, right? So it is basically using a transformer architecture. It is tokenizing. A complete statement is getting divided into multiple tokens, splitted into multiple tokens. And that each token, let's say a token can be a phrase, a token can be a single word. This is known as encoding. Okay. So more of this we will be discussing in our what is encoding, what is decoding, the transformer architecture we will be discussing in the upcoming visual. So basically it is encoding, decoding techniques. As per my understanding, if foundation model is not enough for our requirement, then only we are going for building model. It will be, yeah, that is right, Ramakrishna. If the foundation models are not there for your requirement, surely you will opt for building. If it matches to your requirement, you will just go ahead with that. You don't you don't have to put your head in building your own model. Does generative AI leverage both LLM and FM at the same time, since it's generating images, videos, and text output as well? No, Fayad. The foundation model supports different modality data. LLM supports text data. Okay, so it is using one at a time. As my understanding, compute will be IS, SageMaker will be PaaS, Bedrock will be SaaS. Yes, yeah, you are right, Obed. It's you have put it in the right category. Okay, so coming back to now, we discuss about generative AI services on AWS and the different layers of this. Now moving to generative AI services on AWS, there is a use case being highlighted here. Let us understand the use case. How any company is using generative AI to introduce a new product. Let's say any company wants to introduce a new product. So how they are using generative AI? How they are using the different capability of generative AI? For example, content summarization, content generation, code generation, question and answer. These are the different capabilities of generative AI, right? So let's discuss a scenario here. How a business might implement the generative AI into their workflows. Let's say imagine that you are the CEO of a retail company. The company is any company. Okay? And you want to launch a new line of shoe. You want to launch a new line of shoe to your product line. A new comfortable walking shoe that you want to launch. Now let's put generative AI in practice to meet our business objective, right? Now your product research team has done extensive research, because see, whenever you want to launch any new product in your portfolio, definitely a research is required, right? To study the market, to understand the market, so that you will get certain predictions how it can sustain, or what kind of business your new product will provide you. So your product team has done research, and extensive research they have done on the current market for this new line of shoe, and the team needs to present their findings to the executive team to get an approval, because they have done the research and they want to produce their findings, their research to the executive team, so that once they get approval, it can go to the production, so that the product can move forward. Now the product research team can send the model a report and ask it for summary. So what the product report team is doing, how they are using the generative AI here, the research what they have done, okay, all that data, what they have gathered during the research, that data, they are sending it to the model, the generative AI model, okay, and asking it for summarizing it. This falls under content summarization. And how they are asking? They are asking it by prompting. So they are prompting it for summarizing their research. Now, your marketing team, once they get the summarization, they want to create a social media post so that they can generate the interest around the product launch. They got the summarization, the first that phase is over. That summarization they have produced in front of their leads, their managers, to get an approval. They got the approval. Now they want to generate the content. They want to generate a social media post so that they can create a interest for the product before the product launch, and they can create an excitement, some kind of momentum, right? So the marketing team has access to the executive summary, okay? The summary, what was done here. So they have access to the executive summary of this new product created by the other team, and the marketing team provide this summarized text as input to generate the text for a social media post, and that So the content generation is done just in less than a minute. So the post is ready just in less than a minute based on the input, which is the summarized content which is being provided. Now this boosts the employee productivity and save a lot of time, right? Because the content generation has taken very less time. Now the marketing team needs an image for the social media post. So the content is ready, but now the shoe image they want to be added in their post, not just the content, right? So while the team has some studio images of the product, their product name is London Walker. Let's say they have given the product name as London Walker. Okay. Now what they want actually, they have the image of a shoes. Their product name is London Walker. Now their requirement is that they want to put this shoe, like they want a background, the image, they want to put the image of a shoe, right? And the background of that image, they want somewhere in the London city. They want to shoot this in a London city, means the background should reflect London city. The foreground is a shoe. Now the problem is that they do not have enough time as well as the budget to do a shoot in the London. Okay, to do a professional photo shoot in the London. So what they are doing, they are using generative AI. Okay, by using Gen AI, they have created an image. They got the image wherein the London is there in the background. The image is stylized with London in the background. And foreground, they have their shoe image. So this is an example of creativity and content creation in the form of an image. So image got generated, content got generated by using Gen AI. They don't have to go to London to do a photo shoot. They can just put any background and they have put the London as a background over there. Now, the new shoe has been on the market for a little over a week. It has been launched. Now it's in the market. Now the product team wants to understand how the users are reacting to the social media post. They want to understand the sentiments of their customer. Okay, so how the people are reacting to their post. They have the sentiment data. So using generative AI, they generate the code for visualizing the sentiment data. Okay, what they are doing? They are generating the code. They are using Gen AI for code generation, for visualizing the sentiment data, that like creating charts, graphs, or dashboard. Okay, by using the code generation, what are they doing? They are generating the graphs, charts, or dashboard to visualize the sentiment data, so that quickly they can understand the sentiment. How many positive sentiments, positive comments are there, negative comments are there. Easy to quickly understand, analyze. Okay, that is code generation. Now, for launching this new product campaign, the Gen AI solution helped by generating text, images, content summarization, code generation. Now, what else can it do? Your team also has worked with developers to introduce a new chat-based AI assistant on the website. Because people now want to buy the shoes, they are visiting the website. So what they want? A chat-based AI assistant. So that comes the question and answer. They are using Gen AI for QA. The intelligent AI assistant chatbot. So this helps the customer to find the tracking number for their recent order or assist them with their preferences. That in turn will enhance the customer experience and it improves the business operation, engage the customer by saving the call center timing, right? And also the expenses. So in this scenario, there are so many different Gen AI capabilities are used. Content summarization, generation, code generation, and question answering. Now, what other ways could generative AI have been used in this example? Can you just think and tell me, guys, what are the other ways, possible ways the Gen AI can be used in this apart from these four different capabilities? Anything that is coming in your mind? Okay. Do you want me to repeat the first one? Content summarization. Obey. Content summarization in my example is the one wherein the research team has done a research in the market, because before they plan uh, opt for a new product in their portfolio, they want to do market research so that they can take an informed decision. So they have done market research with their competitors, and that research, what they have done, they gathered a lot of data, so they want to present in front of their seniors, in front of their executives. So they cannot present a lengthy data, right? They have to sum up and show a summary. So for summarization of the research data, they are using generative AI. Okay. No, market research also can be done. Yeah, market research. Okay, that you are giving me. Okay, what other ways? That's very good. Market research definitely can be done by using the generative AI. Voice assistant integration. Okay, good, Manav. Very good. Predictive analytic with product recommendation to customer. Yes, very good. So that is making it more personalized, right, JP? Yeah, very good. And is the traditional data analytic role being eliminated since AI can handle content summarization? The role will not get eliminated, but it will get evolved. Tara? Data analysis has to be done in the data pre-processing, right? So where that the role has been changed, the responsibilities will be changed. Content generation can happen in multiple language. Yes, of course. Of course, Manav, it can happen in multiple language. If suppose you want to cater to different geographical area, social media post, you want to have it for different geographical area and different language, definitely you can do that. Yeah, Pradeep says with this data, they can collaborate with different companies to bring in more bees, combine prompt in a smart way to achieve our objective quickly. Okay, good. Good suggestions. I didn't get code generation as it relates to sentiment about the product. Code generation is Fayad here is about understanding the sentiment of a social media post. The post that you have done before the product launch and after the product has been launched, how the customers are reacting on the social media post. Okay, because we have so many posts been gathered. Now the sentiment analysis is done by you by understanding the wordings of the post, right? How the people are commenting, the wordings of that, whether the wordings are positive, whether it is negative context, whether it is neutral. So for that you need to write you need to get a program for that. A code program is required which will analyze the sentiment, whether it is in the positive, negative context or which context. So for that, Gen AI you are using for generating the code. Okay. Supply and demand to cater production based on response. Yes, if someone asks irrelevant question, should not give wrong answer. Ramakrishna, you're talking about the chat bot, right? Or is it for me? Okay. Yeah. So we can use Gen AI for personalizing, as you have rightly mentioned. Someone has mentioned here generating the content in different languages. That was also a good suggestion. The different culture, addressing the different culture, because see the content which it is generating for a social media post, it has to be more personalized based on the geographical area, right? Because there are certain words which are not acceptable in certain geographical area, certain countries, right? So keeping that, it has to keep that also in mind. So that culture the language. For that also we can use generative AI. Personalization we can use. Advertisement, for advertising, for targeting the audience, we can use that. Okay. And what else? Yeah. Yeah. So yeah, these are the different ways, additional ways we can use the generative AI. Good suggestions. Thank you so much. Okay, code generation, Salma. Code generation. See, somebody has written a very bad comment for the. Okay, simple example like yesterday's class. Many of the chat was completely flooded, right? The meeting chat was flooded, and we wanted to, because we cannot just read each and every. So we wanted to find out the satisfaction level of our students, right? So let's say we are using generative AI. We have given all this chat to generative AI to find out the positive comments, to find out the negative comments. Okay, positive, negative, basically segregating and giving us the score. Positive, let's say 40% is there, negative is 60%, or let's say negative is 50%, and then we have neutral. Okay, so this is what is sentiment analysis. We want to do sentiment analysis. We want to understand the sentiment of the comments what they have put on our post. So for that, to understand that, we are using GenAI to generate a program for us, and that program will perform the sentiment analysis.
So I hope you are enjoying the video so far. Just a quick reminder, don't forget about the free masterclass on AI/ML, Gen AI and Agentic AI that we are hosting. It's packed with everything you need to break into the AI/ML world, from building a solid portfolio to landing that high-paying job. Trust me, you don't want to miss this opportunity. Make sure to grab your spot by registering through the link given in the description below.
Okay, now coming to the benefits of generative AI. So already we discussed all this, and you people have already suggested in the previous example, personalized customer interaction, generate novels. So this is like the same match with our example, what we discussed, right? Efficiently adapt pre-built models to business use case or achieve productivity gains through automation. Basically, generative AI or AI is giving us another advantage of automation, right? We are able to automate multiple tasks using this. Okay, now coming to what is foundation models. What are foundation models? Let us understand foundation models. The foundation behind the foundation model. Okay, now see, you all know that Gen AI is powered by FMs, right? And what are FMs? FMs are pre-trained. Can you see this? Pre-trained. FMs are pre-trained on, important point I would like to highlight here, internet scale data. Keep that in mind. Internet scale data. So foundation models are pre-trained on internet scale data, and generative AI is powered by foundation models. So generative AI has learned from such a huge amount of data. That's why it can generate any type of content, right? Unlimited capacity it has, unlimited, not capacity, sorry, capability it has, right? So it is trained on, pre-trained on internet scale data. Now with foundation models, instead of gathering label data for each model and training multiple models as what we do in traditional machine learning, you can adapt a single foundation model to perform multiple tasks. Can you see? Unlabeled data. Internet scale data. Is it possible, guys, to label such internet scale data? Just impossible, right? So with foundation model, instead of gathering a label data for each model and training multiple models as what we do in traditional machine learning, what we do in foundation model, you can adapt a single foundation model to perform multiple tasks. Like we discussed earlier, multimodal. A single foundation model for, okay, here itself it is highlighted. Content summarization, content generation, code generation, right? So it can adapt to multiple tasks. It can perform multiple tasks. So these are the tasks: text generation, text summarization, information extraction, image generation also comes in this, or chatbot interaction, question answering. So all this with a single. In traditional machine learning, what are we doing? For text generation, one model, image generation, another model, question answering, another model, right? So what we are doing? We are giving a label data and we are creating multiple models, one for each task. But here, a single foundation model to perform multiple tasks. So foundation models can also serve as a starting point for developing more specialized models. Now, when I say this, what does it mean? It can be a starting point for developing a more specialized models. What does this point means, guys? How can we develop a more specialized models out of a foundation model? Yeah. Retraining, no, not exactly retraining. We call it as by feedback. Okay. By extending the FM's data source. Yes, Fayad has rightly mentioned FM's data source. So basically, we do fine tuning. Remember, we do fine tuning. The RAG and all what we discuss comes under fine tuning. So what we do, we use the foundation model and we make it domain specific. We make it more specialized for our requirement. So what is a foundation model? A foundation model is a pre-built machine learning model trained on a large amount of data. How do you define foundation model? It's a pre-built ML model trained on large amount of data. As I already mentioned, internet scale data. So the result is a model that can be adapted to a wide range of tasks. So unlabeled data is given to the model. Can you see? Unlabeled data and different type of data. Can you see this? This is all these images showcase that the data is raw in the sense, sorry, unlabeled, and different type of data is being given to foundation model for training, and it can, the output of that, it can adapt to a wide range of tasks. These are the different types of tasks highlighted. Broad range of general tasks. Unlabeled data. This includes raw data such as images, text files, videos. Means we are not giving labels, okay? To provide context to a data, we are not giving label. Pre-training is a process of training a model on large amount of unlabeled data, okay, to support different tasks, broad range of general tasks. And foundation model, it is now trained on massive amount of general domain data, not a specialized domain data, general. Adapt, next step, the foundation model can be adapted to perform a specific task with the help of the prompts. We provide prompt, like we discussed in our previous example. I wanted to get content summarization. I gave the prompt, please summarize this content, and I provided the content. It will summarize. I wanted to generate the code. I gave the prompt accordingly, right? So we have to say, we have to tell what we want, tell the model what we want. The next is fourth step, broad range of general tasks. The foundation model is ready to perform broad range of tasks, all these different tasks. Okay, so foundation models have broad applicability and adaptability, not only because of the massive training data set on which it has been trained, but also the billions and trillions of parameters that result from their training. Okay, so in the training, it is learning billions of parameters, and that makes the foundation model rich with the features, with the patterns, and hence it can be used for different tasks. Okay, how can the foundation model be tuned to use for our specific need? We can tune this foundation model. Now, since we are discussing AWS, we can tune this by using the AWS Bedrock service. Just to quickly take you to the Bedrock dashboard, let me, where is my console here? Yeah. So here, if I just go for custom model, you can see custom models. customize a model with distillation, fine-tuning, or continued retraining. So here we have the option to fine-tune a model. I will show you this in our lab. P. Kumar says, but even for Gen AI, also you showed same content summarization. So that is what you forgot our discussion, Kumar. What I said, Gen AI is powered by. Yeah, Kumar, Gen AI is powered by. Can you complete my statement? Yes, right, Anubhav and Chandan. So Gen AI is powered by foundation model, right? And foundation model, that is what we are discussing now. Since it is powered by foundation model, we need to understand what is foundation model, right? Okay, so I guess there is a question from Jasmine. Jasmine, please go ahead with your question. Okay, Rajiv says, can it also be done with our AWS service using Python? Yeah, of course. You can write a script also, Python script also. You can. Okay. Okay, Anubhav says, and FM is powered by deep learning, right? Foundation models are powered by deep learning. Yes, it is also powered by deep learning. If it is like image data, it has to, yes, of course, because foundation models multimodality support. So for image data, definitely it uses deep learning. Is AWS Bedrock is RAG? Bedrock is a service. We don't call it as a RAG. RAG is something, a capability which is supported by Bedrock. You can implement RAG by using Bedrock Mana. Fine. Now, how are foundation models created? So we have already seen the foundation model, but once again, I would like to talk about the life cycle of foundation model. The foundation model lifecycle is a comprehensive process which involves several stages. Okay, and each stage plays a crucial role in developing and deploying a reliable and efficient foundation model. Now, to create a foundation model, the important thing is data. Again, data, right? Because we're talking about the model. Could be a traditional machine learning model, could be a large language model, could be a foundation model, ultimately model. And when we say model, what is that? Data. So we have data selection. Okay. So that is the one thing, the first thing, the most important thing required to build a foundation model. So unlabeled data can be used at scale for pre-training. Okay, because it is more efficient to obtain compared to a labeled data. Unlabeled data include raw data like a text, images, file, videos with no meaningful informative labels are there to provide the context. Keep that in mind. Unlabeled, what does it mean? Unlabeled data is the raw data that is nothing but your text data, images data. Here, raw data, the context of raw means unlabeled. It is not been labeled. Remember the context. So, images, text, videos, audios, files, all these are the unlabeled data, means that does not have any a context or the labeling being done. So, foundation model require training on massive data set from, as we know that massive data set is required, but from diverse sources. Diverse sources, the data is required. Otherwise, it will become very, it will be a bias. The output could be biased if suppose the data is coming only from one sources, right? So biased data and a large amount of data. That is the first thing. Next step is pre-training. So we saw in our previous visual. So you know that the traditional machine learning model rely on supervised, unsupervised, and reinforcement learning pattern, right? Supervised, unsupervised, and reinforcement learning pattern. But FMs are typically trained through self-supervised learning. Machine learning model. How do we, like what type of algorithms are there? Supervised, unsupervised, and reinforcement, right? Now you should never forget this because I have repeated multiple times. Supervised, unsupervised, reinforcement. Supervised is the one which needs a label data. Unsupervised, unlabeled data. Reinforcement is one that is like trial and error, right? But foundation models are pre-trained through self-supervised. Self, okay. self-supervised learning. With self-supervised learning, labeled examples are not required. It is just like self-learning. How do we self-learn, right? So label data not required. Self-supervised learning makes use of the structure within the data to auto-generate labels. Okay? For example, let's say I am reading a book on transformer architecture. Let's say I'm reading some notes or a book on transformer architecture. Now I read, I understand, and what I do, I just highlight the important points. Or what I do, I take the notes out of that. In my own language, I just write down the notes. I don't just replicate each and everything. Let's say 100-page book is there, and I have taken the notes out of that, which is it has come to 5 pages. This is self-supervised learning. So this is how the foundation model does. Self-supervised learning makes use of structure within the data to auto-generate labels. Remember that. Now, during the initial pre-training stage, the foundation model's algorithm can learn the meaning, context, and relationships of the words in the dataset. Okay? In the pre-training stage, when the algorithm is getting trained, so that we call it as a pre-training stage, the foundation model algorithm, what it does, it learns the meaning of the words, the context, the relationship of the words in the data set. Okay? Example. Let's say the model might learn whether drink means a beverage, that is a noun, or swallowing the liquid, the verb, right? Because a single word can have multiple meaning. A bank of a river or just a bank. The word bank will have multiple meaning, like a financial institution or bank of a river, right? So here whether drink means a beverage, which is a noun, or could be a verb, swallowing the liquid, right? So after the initial pre-training, the model can further pre-train on additional data. And this is known as continuous pre-training. Continuous pre-training. So once the initial pre-training is done, a model can be further pre-trained on additional data. And whenever a new data comes, what we do? We pre-train the model. We retrain the model. Okay? So that falls under continuous pre-training. So what is the goal? The goal is to expand the model's knowledge base. It should not become obsolete, right? So therefore, to maintain that goal, we have to do the retraining. So that we can improve its ability to understand and generalize across different domains or tasks. Otherwise, it will not be able to understand the new things which have come in the market, right? So to make it understand, we have to do the continuous retraining, or you can call it as a retraining also. Next is, once the pre-training is done, so first step, what we said, data, right? So data selection. The next step is pre-training the model. And next step is, the third step is optimization. So pre-trained language models can be optimized through multiple techniques. Now coming to those techniques which we have already highlighted before, but I would like to highlight it once again. Give me a second, let me clear my screen. Why is this not happening? Fine. So first step was what I said, data selection. The second one is pre-training. The next one is optimization. Okay, now what is optimization? As I said, the pre-trained language models we can further optimize through multiple techniques. For example, prompt engineering, RAG, retrieval augmented generation, fine tuning. Okay, so what we are doing? We are further optimizing the foundation model using these techniques, either prompt engineering, RAG, or fine tuning on a task specific or a domain specific data. Okay, So these methods will vary in complexity depending on which one you are using, also vary in the cost. So just keep these techniques in mind. We will have in-depth discussion on these techniques in our upcoming modules, right? So just I would want optimizing foundation model optimization techniques keep in mind. Don't raise any question on this because otherwise it will be like completely deviating from this topic. Prompt engineering, RAG, fine tuning. Next step is evaluation. We are discussing how are foundation models created. In that we discuss first step data selection, second step pre-training, third one is like optimization, further one, last one is evaluation. Now optimization is optional, okay, not mandatory. You can after pre-training, you can opt for evaluation. Now whether you fine tune a model or you use a pre-trained model, the next logical step is going to be your evaluation. Evaluating the model, what is being trained, what is like what model you have built, right? So, an foundation model's performance can be measured using metrics. We have to use appropriate metric and a benchmark. How do we check the performance, right? Some benchmark we need to set, some metric we need to use because there are different metrics. So evaluation of model performance and its ability to meet business need is important. Whether it is meeting business need, if yes, yeah, then you can go ahead to deploy. Next step is, final step is deployment. So when the foundation model meets the desired performance criteria, you are ready to deploy the model in the production environment. So deployment can involve integrating the model into application. You want to integrate into an application, you can do that. Integrating into an application or integrating the model to an API or other software systems you can use. And then feedback. Why a feedback? For continuous improvements. Once it is deployed, what we do? We monitor. We monitor the feedback for continuous improvement. So after deploying, the model's performance is continuously monitored and feedback is collected from users, from domain experts, or from the stakeholders. Now this feedback along with model monitoring data is used to identify areas for improvement. It can detect the potential biases. It can detect the drift and inform the future iteration of the model. So the feedback loop permits continuous enhancement of the foundation model through fine-tuning, through continuous pre-training or retraining. Okay? Continuous pre-training or retraining as when needed. So these are the different phases of foundation model. These are very similar to our traditional machine learning model, traditional machine learning pipeline that we discussed, machine learning life cycle that we discussed. There also we perform data pre-processing. Here also same thing, data selection. Then we train the model. So here we call it as pre-training. Okay. Then we evaluate the model performance. Then we deploy. So same things are there. Okay. Only few terminologies here and there differ. So these I have already explained. Okay. Now coming to how does this unlabeled data gets processed? Let us understand the transformer architecture. Before that, I guess there are some questions. Let me take the question. Yes, Pikumar, you're right. RAG is used for adding supplement data, so it's unsupervised learning. Unlabeled data can be featured. Yes, it's unsupervised. That's right, PR. Self-supervised, same as unsupervised. Not exactly same as that. Okay. Little features it differs. So this is large. So this is large amount of available data is unstructured data. Correct. Okay. So there are multiple questions coming here for self-supervised and for unsupervised. Can you tell me, guys? Does anybody know what is self-supervised and what is unsupervised, or what is the difference between that? Learning based on existing data is self-supervised. Learning based on existing data. Target is there for supervised. Self-supervised generate labels by itself. Okay. While no target for unsupervised. Okay. So for labeled and unlabeled. Okay. Self-supervised creates own labels itself. Unsupervised clustering and dimensionality reduction. ML models are supervised and unsupervised. FMs are self-supervised. Very good. Okay, so I am getting lot of good and correct answers. So as I scroll up, P. Kumar says learn based on existing data itself is, see, data is always existing, right, P. Kumar? It's always historical data, whether it's supervised, unsupervised, or self-supervised, it's always historical data. Target is there for supervised. Yes, Rajiv, that's right. Self-supervised generate labels by itself, that's correct, Payal. While no targets for unsupervised, that's correct, Rajiv. So far, labeled and unlabeled, okay. Self-supervised creates own labels itself, unsupervised is clustering and dimensionality reduction, that's correct, Roshan. And Pradeep says ML models are supervised, unsupervised, FM models are self-supervised. Yes, Pradeep, you're right. Self-supervised is between labeled and unlabeled data. Okay, correct, Manav. Unsupervised is completely dependent on the multiple layer of learning. Self-supervised sort the data by itself, unsupervised feed the data. Okay, okay. So, people, you have given correct answers. Many of you have given correct answer. So, self-supervised generate the label itself. Okay, unsupervised does not generate the label. It does not create a label. Self-supervised create label of its own. Remember that. Yeah. Yeah. So coming to the transformer architecture. What is transformer architecture? Okay. How does this unlabeled data gets processed? So there is a transformer architecture which is being used. Large language models are deep learning foundation models based on transformer architecture. So LLMs can be based on a variety of architecture, but the most common architecture in today's I would say the in today's model is the transformer architecture that it uses, which is one of the popular architecture. So a transformer architecture is the type of neural network that is efficient, easy to scale and parallelize, and can model interdependence between input and output data. Input, what is, let's say, what is the color of a sky? That is the input. So it inputs, and this is the output that it provides. It decodes the output. Let us understand more about transformer model. Okay, so large transformer models can provide use cases, for example, natural language processing or machine translation or DNA analysis, protein structure analysis. So these are the different use cases of transformer model. And the various benefits of transformer model is that memory efficient. It is memory efficient and can be trained in parallel on GPUs. Memory efficient and you can train it in parallel. That's why parallelize is highlighted here on GPUs, graphics processing units. So compared to its predecessors, like we had recursive neural nets, the transformers architecture are parallelizable. So that will speed up the processing. So it is possible through GPUs. Its speed up through processing increases because of the GPUs. So transformers do not process words sequentially one at a time. Instead, they process the entire input all at once during the learning cycle. Okay? Not like word by word sequentially, but they process the entire input while they are learning. This makes the training process highly parallelizable. And that result, transformer requires significantly less time to train the model. We can apply more computing power to speed up the training because it is capable of parallelizing. So the total training time is reduced because of the transformer architecture. And this can lead to a model that can scale well with enormous amount of data. So the transformer architecture is a type of neural network that is efficient. Efficient how? Memory efficient. Easy to scale on the enormous data. Parallelizable because it does not word by word, it doesn't process it sequentially. Instead, the entire input it will process. So parallelizable. It can retain and use information about meaning and position. Transformer models also take advantage of positional information. So this provides the model data on the location of word in the input sequence. Now where the word is located in this input sequence, let's say where is the word neural is located, or where is the word architecture is located in my complete data. So it can retain the positional information, location of the word in an input sequence. If you are inputting a sentence, let's say this complete sentence, the model captures the importance of each word and the relationship between the words, because otherwise it will not understand the context, right? So each word, position, sequence, context. Okay, so it understands the importance. Let's say if I remove this word from here and can model between input output, the meaning completely change. The importance gets lost. The significance of that will be lost. Or if I remove the word transformer itself, or if I remove the word neural itself. So basically what is happening? I'm making it meaningless, right? So the importance of words, the relationship between the words, that also it captures. How a human does this? We does this by understanding what verbs are, what nouns are in a sentence, how adjectives relate to nouns, and how words relate to every other word in the input sentence, right? That is how we understand the context of the entire statement. We just don't read only word. We don't take only word, right? But rather we do comparison. Nouns with the adjectives, with the verbs, with the, right? So different, we use basically the grammar to understand the context. The model follows a similar process, but it is encoded in mathematics. It pay attention to multiple things at once in different ways. It position encoders, position encoders allow models to prevent ambiguous meaning when a word is used in other parts of a sentence. It's quite possible one single word is being used multiple places in your sentence. And as the word is being used in different sentence, the context of that is getting changed. Possible the context in one sentence is different than the other sentence. So what it does, position encoders that helps to prevent the ambiguous meaning. Position encoders helps the model to prevent the ambiguous meaning when the word is used in multiple parts of the sentence. The example which I gave, bank. Okay, let's say I am using a sentence, I went to bank to withdraw money. I went to bank to withdraw money. Okay, now the word bank is here. The other sentence is the boat anchored by the bank. Now here also we have the word bank. Now this has two different meanings. So while both statements include a word bank, in context each bank means something different due to their position. So that's why position encoding in a model allows the transformer model to differentiate the semantic difference between these sentences. Semantic and syntactic, right? These are the two things in a sentence. So it can differentiate the semantic the differences between these two sentences. That is known as position encoding. Components of foundation model. So we have already discussed all these things. So I'll just move ahead. Now coming to generative AI in practice, but I guess there is some challenge. Okay, so we have what is parallel. I hope you have understood, Rajiv. Neural network we are going to discuss, Rajiv. Transform is only for unlabeled data, right? Under unsupervised learning. See, Anubhav, currently we are discussing about foundation models, right? Foundation models are semi-supervised, which can label by itself, right? So it uses transformer model. That is what we discussed so far. The different architecture that is being used, the transformer model, the foundation model uses transformer architecture. It is based on transformer architecture. Okay, and what is transformer architecture? It can scale because it is being trained on huge amount of data. So scalability is there from data perspective. Parallelizable is there from tokenization perspective. It is not like token by token or word by word. It is processing sequentially. Instead, the entire input it processes parallelly. Okay, so parallelizable. And there is a memory retention is also there, right? Memory efficient is there, so retention. Yeah, so multi-layer neural network is used in deep learning, that is chained together. Yeah. Now coming to generative AI in practice. So now what we discuss the transformer architecture, let us understand so that your questions will get you get more clarity on the transformer architecture what we were discussing, right? How the transformer model works. Let us understand with an example. So, as I said before, LLMs are deep learning FMs. A deep learning, as rightly mentioned by Agis Payar, it's a neural, matrix of multi-layer neural network. So, LLMs are deep learning foundation models based on transformer architecture. Now, these models can be unimodal, which can process only text data, or could be multimodal, which can handle multiple data types like text data, image data, audio data. So unimodal or multimodal. The FMs could be unimodal or multimodal. Okay. Now LLMs can be based on a variety of architecture. But as I said, the most common and the most popular in today's you can say era or in today's model is the transformer model. Okay. Now, transformer-based LLMs, we call it as the models which are using transformer architecture. We call it as transformer-based LLMs. Okay, another terminology. So, whenever such terminology come in front of you, you should not get confused. It's the same thing what we discussed. Transformer-based LLMs are the one that uses transformer architecture. So transformer-based LLMs are powerful models that can understand and generate human-like text. They are trained on vast amount of text data from the internet, from books, from lots of other sources, and learn pattern and relationship between words and phrases. Transformers are type of neural network architecture that transforms or changes an input sequence into an output sequence. So consider the input in this example. This is the input. Now you ask Gen AI to complete the following sentence. A puppy is to dog as kitten is to dash. So this is the input sequence. We are expecting the output sequence of this. So what a transformer based LLM does? They learn the context and track the relationship between sequence components. Tokens. Now let us understand what is tokens. Tokens are the basic units of text that the model process. Tokens can be a word, just one word, let's say A, or just a puppy, a word. It could be a phrase, let's say the complete phrase, or an individual character, just an A. Okay, just an A could be a token, or just a dot. A dot could be also a token. So it's the basic unit of a text that the model process the tokens, and token could be a word, a phrase, a dot, a period, okay, individual character. Tokens also provide the standardization of input data, which makes it more efficient for the model to process. Okay, now in this example, a puppy is to dog as a kitten is to cat, we know, right? It might break this into multiple tokens, wherein, okay, just a minute, let me clear my screen. Okay, so in this it could be a puppy is to dog as, so these are all individual tokens. Okay, so it has done multiple tokens here. Now, embeddings and vectors. So once the tokenization is done, it does embeddings. Embeddings are numerical representation of tokens. Once the tokenization of a sentence is done, it performs embedding, which is a numerical representation of token. Let's say A, it is giving the number 1, the puppy has 2, this is 3, this is 4. Basically, it is encoding, it is embedding, it is converting token into numerical representation. Each token is assigned a vector. We call it as vector. Now, each token, when it is assigned a vector is nothing but a list of numbers. Okay, embedding and vectors. Tokenization is splitting the sentence into different tokens, and embedding is representing a token. A numerical representation of a token is embedding, and vector is a list of numbers. So each token is assigned a vector that captures its meaning and relationship with other token. The vector is the one which captures the relationship and the meaning with the other token. Now these vectors are learned during the training process. and it allows the model to understand the context and nuances of the language. Now, for example, the embedding vector for the token cat might be close to the vectors for, let's say, if I go to here. So these are the different tokens, and the different token have been given different vectors. Now, which one is close to the kitten, that it will take after it performs after it gives the vectors. Okay, so the embedding vector for the token cat might be close to the vector for kitten in the embedding space. So indicating that they are semantically related. This way the model can understand that cat is similar to kitten without being explicitly programmed with those relationships. It is able to understand because based on the vectors it is identified. Now LLMs use these tokens, embeddings and vectors to understand and generate the text. Tokens, embeddings and vectors to understand the text and to generate the text.
So
The model, yeah.
how this okay, once is tokenized and then there is a embedding vector assigned to each token, and then how does it pick the close number? Like we have now 1, 2, 3, 4, 5, right?
I have just given an example to simplify 1, 2, 3, 4, 5. It won't be like that.
Okay, but in an example only, like how will it like what will happen now? It will pick up the closest number or like what? I didn't, sorry, I missed that part.
See, it will, once the vectorization, embedding and vectorization is done, it
Yes.
will try to select the closest word to this kitten. I will go to the next slide where the visual is there so that you will be able to understand it properly. Okay, let me just complete this point. Yeah, so I was talking about vectorization, embedding done, and what else? Token is done. Yeah. So I was talking about the LLM. So LLM use these three different things to understand the text, and it can capture the complex relationship in language so that they can generate the contextually appropriate text for you. It can answer the questions, it can summarize the information, and it can even provide you the creative content. Okay, so this is what we discussed so far: tokenization, encoding, word embedding, decoding, and output. Let me quickly provide you few information about the decoding. So, the process of how a transformer model completes a sentence consists of these 4 steps. Okay, how a model completes consists of these 4 steps. Tokenization and encoding, wherein the model breaks down the input into sentence into individual tokens, word or subword or character, and convert this token into the numerical representation, because machine learning can understand the numerical data. It can process the data fast numerical, and then that the model can understand. Next is word embedding. The model maps each token to a vector, dense vector representation. Dense vector representation, which is known as word embedding, which captures the semantic and syntactic information of the token. Word embedding captures the semantic and syntactic information of the token. Okay, so the model maps each token, could be a word, each token it maps to vector representation. Next is decoding. The transformer model processes the embedded token through multiple layers of self-attention and feed-forward neural network to generate the contextual representation of input sequence. Self-attention and feed-forward, because the neural network will have multiple layers. So one layer forwards the information data to the other layer. The model then uses this representation to predict the next token in the sequence, and that is where you get the output. These are the four phases of transformer model to complete the sentence. So the model generates the most probable next token based on your input sequence and the learned pattern from the training data. Now, what the model does, the model repeats this process until the entire sentence is completed or until it meets a stop condition. Okay, now let me go to the next visual where we can see the example here. So here, this is the example. So that was just 1, 2, 3, 4, which I took was very simple. Just I used a simple example over there, but it is not exactly like that. Example of tokenization and encoding. So in the first step, the transformer model breaks down the input into smaller parts so that they can be converted to numbers, which we call it as encoding. Now these smaller parts, as we discussed, tokens are known as tokens, can be word, phrase, or individual character or period, right? Now tokens also provide a standardization of input data, which makes it easier for the model to process. And then once the tokens are done, it can be embedded into multi-dimensional space. Finally, tokens can be embedded into multi-dimensional space. Now here you can see the different numbers are given here. Okay, if we go to this visual, now words with similar meaning are located close to each other in this vector space. So now after the step of tokenization, the transformer model, what it does then encodes this token into n-dimensional vector. You can see this is the n-dimensional vector. These are multi-dimensional numerical representation of words grammar. It is not a single dimensional. Transformer model, what it does after the tokenization is done, it encodes the token into n-dimensional vectors. A vector is basically wherein the numberings are given, right? So
Sorry,
n-dimensional.
it will only embed that sentence that it has tokenized into the vector. Like how are these values are coming in the vector then?
That is what is done by the algorithm. That is what his algorithm has got instructions. So it is not the numbering what we think, but that is how the algorithm process the data, perform
So,
the encoding and decoding.
so it will place like the numbers of our sentence in a vector and then also the other values in the vector, unlimited num values.
See, it completely depends on how many dimensional it is. Accordingly, it will have some set of numbers that it will use, or what we call it as array of numbers are there in the vectorization.
But those numbers like will be pre-built in that vector, or those numbers are the ones that comes from our sentence.
That comes from our sentence. Based on the sentence, based on the context of the words, accordingly the numbers will be given. And based on the words which are repeated in different data point, different sentences.
Okay.
So it is not like pre-built. Okay.
But still, I don't understand like how are then these words coming? Kitten, like felony, old,
So
dog,
this it will have these
puppy.
words. It will have these words
In our
in the
sentence, we don't have it.
training data on what it has been trained on.
Okay. Okay. It will compare with the training. Okay, I got it. Okay.
Exactly. It is already trained, right? Training data it already has this. So it has captured the features of that.
Okay. So it will capture our numbers and then it will match, put it into the training data and then it will match the progress.
Exactly.
Okay, got
Yes.
it. Thank you.
Okay. So words with similar meaning are located close to each other in the vector space, and that is what it makes it easy for for to complete the sentence. The transformer model can complete the sentence. Basically, it is understanding the trying to understand it understand the semantic and syntactic meaning of a word. Okay, so transformer model may have thousands of dimensions for encoding a word, not just few dimensions. So to simplify this in this slide, we have we have just two-dimensional spaces given in this. But otherwise, if the transformer model uses um, can use thousands of dimensions. So it's basically a multi-dimensional numerical representation of words grammar. Keep that in mind. To understand the words grammar, multi-dimensional numerical representation it does. Words grammar or the words meaning, the usage of the word. Okay. So that is how now, this is how it completes with the most, once all of the tokens have been encoded, the transformer model performs the decoding action. It uses the vector representation to predict the requested output. So it has built-in mechanism to focus on different part of the input and guess the matching output. It has like complex mathematical techniques are there, which are integrated with the algorithm that helps to decode and that helps to evaluate the different output and select the most, you can say, most probable word, the word with the highest, I would say, probability. It select.
So Malai, so with respect to this transformer and the coding, the vector coding that you have, tokenization and the vector coding that you have showed on that slide, I see there are some numbers there which are like randomly assigned. Are those numbers from the tokenization systematically assigned? And is that what
We don't see these are actually the internal architecture of an algorithm, internal mathematical calculation done by the algorithm to assign the numbers.
Okay. So once the numbers are assigned, and then the next slide you have shown wherein we have the word embedding, right?
Yeah.
And the word embedding, I don't see any numbers there. So how will the
So
numbers,
here it is not highlighted here, but you can see it is a graph, right? Two-dimensional graph. So there is definitely each of this word has a value.
In
Okay.
the algorithm, actually, yes. Yeah.
Yes, yes.
So then each of them has a value, and the numbers what we have on the vector and the tokenization, how will it match it to these numbers? That's somewhere I'm not clear. Like how
We'll
is it?
find the closest number.
Correct.
Okay, so the cat has 9.2.
Exactly.
So now if I go back to my vector or tokenization and vector slide, suppose let's say my kitten has, how do I how is it doing that calculation? Like 9.2 is the closest we said, right? So how
Okay,
How does
that
it
is
find
what.
the closest? Closest to what? To kitten?
That is
To
what.
last
See,
point?
okay, let me tell you, like we use the example about the bank, right? Uh, I went to bank or the and I'm like I sat on the bank of the river. So how do we find that, right? So how what logic we use, what kind of see we have learned the grammar behind the language, the nuances of the language, right? The similar thing the machine learning model or the foundation model does. It try to understand the semantic and syntactic meaning of that, and for that it divides the sentence or it performs the encoding, convert that into mathematical representation because models understand mathematics. We understand grammar. So the grammatical representation of any sentence, it is internally converting into numbers. The algorithm has certain instructions to perform this.
got it.
Okay.
So it basically find the closest number on its own.
Yes, of course.
The algorithm has, because in
It does its
Python,
own. Just we are trying to understand how it does, but otherwise it does it of its own. We don't have to. We
Okay.
don't have to do anything. It is completing the sentence for us.
So you are just
But
explaining
what
the
if it's
total
a new
working.
word? What if
Yeah.
it's a new like ebonics or something that is not in the dictionary? Because I assume it's taking our base understanding, like an entire dictionary, assigning these values to it, and then when
That's
it sees it again, it's
okay.
recognizing
That's a
it.
good question. What if it is not there in the dictionary? Then what do you think? What we need to do with the foundation model? Tell me.
You retrain it.
Retrain.
Exactly, exactly. We have to retrain it, right?
Give
What
it
is
to
We
what
retrain.
is
Yeah.
what
Who
goes
retrains
comes
it
out?
though? Does it
Sorry.
automatically retrain itself, or in what? How does that retraining happen?
Okay, let me tell you, we can automate this process as a new data comes. We can perform the like CI/CD, what we call it as. So we can automate this, or we can do it as a manual activity. We can trigger the retraining of a model whenever the new data comes. We can schedule also.
How do you manually retrain it? Do you go in and just define the word for it? Like put it in the dictionary for it
Wait,
with
wait,
your
wait, wait. No,
definition?
no, no. That way I'm not saying. I'm saying whenever a new data comes, we are feeding the new data. We are training the model with the new data so that it can understand those new words or whatever new things have come in the language.
So I've heard that there are basically data mining camps that are happening around the world where people are literally inputting data to train models to interpret words certain ways. So is that true? Are they actually defining words for the model, or is the model watching how we're using the words and retraining itself?
No, it cannot train itself. See, it can train itself for whatever language nuances it has learned. But something new has come, how it will know. It cannot learn a new word of its own. If it is not there in the dictionary of a model, a new word, it cannot learn of its own. It can learn the sentences in which the words are used, what it is already been trained on. If you are using any of the word on which it has been trained on and you are framing a new sentence or giving us something new, prompting something new, it can understand. But a new thing, definitely a retraining is required. So that's why we have to do retraining periodically, depends on as how often the real data is real time or the real world data is getting changed.
And then what about different models using different words differently? Like, is that why we should use different models? Because one model may use a word in a positive way, one model may use a word in a negative way.
Okay, that completely depends on how the training has been done.
Okay.
Okay, it completely depends on the training. How the model is been trained, accordingly the model behaves. What kind of data it is been given for model for training, accordingly it behaves. What kind of metrics you have selected to check the performance, check the to validate your model, accordingly the you can expect the output from the model. So it's completely based on the training process.
So this encoding value for the token, it could be different for different models, and that is driven by the algorithm that model is using. Is that correct?
Exactly. Yes, you're right.
It is not generic, like A will have 1037 in all the models.
No, 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 not at all.
Okay. Okay, because I thought this is like very generic grammar, like A, puppy, in every model it might have same value, but you are saying that would not be the
No,
case.
not at all. Not at all.
Because language, LLMs, like language, it is consistent all around the world. Like puppy has same meaning everywhere. So
Language is consistent, but not necessarily that the same sentence is being given. The sentence phrasing might differ, right?
yeah, but I'm talking about encoding value for a
The
particular word.
encoding value it depends on the because encoding is not just mapping to a number. It is basically why it is doing vectorization because it has to preserve the meaning, the context of that. That is why it is doing. It is not just mapping to a number.
I think we did the one example in Python. Like, when we were having our Python classes, then we stored some data in the vector and then we had another data in a list, and then we compared it and get the closest. So I remember something we did in Python
Okay.
classes. Yeah.
Yeah,
So it's mathematically it basically chooses the closest number actually from the algorithm. Yeah.
Yes.
Thanks for watching. If you found this video valuable, don't forget to subscribe for more insights on AI technologies. Also, be sure to register for our free live masterclass on AI, ML, generative AI and agentic AI, where you will gain hands-on experience and learn directly from industry experts. Click the link in the description below to sign up and begin your AI journey. And make sure you check out this video next.